I was
Good morning,
as I was out of station. Yes, Maranika, good morning. Okay. So students, that yesterday that I had a discussion out of stations that I was in Nimapada. So it's 15 minutes back. Yes, Niharika, good morning. Good morning, Niharika. Adhyasa Dubey, good morning. Okay, students, that today we'll have to start a new topic of that of enzymes. Okay, in our chapter enzymes, we'll have to know about a new topic. That topic is that of mechanism, reaction mechanism. As you know about in chemistry, also here you can have to know about that of that is mode of reaction, how enzymatic reaction occur. Okay, so we'll have to know about that of enzymatic reaction. Very mindfully, you must have to listen it and hear it. Okay, and if doubt persists in mind, you should have to tell me. Okay, it is very important that you should have to remember it. That is mechanism of action, student. That is mechanism of actions. You write down that. That is mechanism of action. Mechanism of action. Okay, mechanism of action. You see that. We'll have to draw a diagram that is also in our NCRT. Okay, in your NCRT, such a diagram is also, it is x-axis and it is a y-axis. Okay, y-axis. Y-axis is meant for potential energy, for that of potential energy. Okay, potential energy, and that x-axis, that is progress of action. That is progress of action. Okay, progress of reaction. Sorry, progress of reaction. Okay, reaction. Again, I am writing little bit wrong. That is progress of reaction. And here is that, you see that, here is that of substrate. Okay, here is that of substrate. And from that substrate, you see that, that means substrate will transfer into that of product. That means enzymes. Before I am going through it, I am just telling about you that, suppose that means sometimes you are also suffering from fever. Okay, that your body temperature increased to certain extent, that 98.4 degree Fahrenheit, and it increases to 99, or that of 100 or 101, 2, like this. So body temperature increases. That means why? That means your body temperature increases. That increase in body temperature does not mean that you are suffering from a disease. That is, fever is not a disease. Fever is just a symptoms of pathogens, foreign pathogens entering our body system. You remember, students, that that means you are suffering from fever. Sometimes you are suffering from fever. That means your body temperature increases to 99 or that of 100 Fahrenheit, and so that you are feeling bad, and that means when you are touching your body, that means feeling warm, hot. It is owing to that of body temperature increases. But increase in body temperature does not mean that you are suffering from a disease. That means you are suffering from disease. There is no question of fever is not a disease. But fever is what? You see that our body systems, that means our body system has so many pathogens. You know that there are so many pathogens in our body system. But if foreign elements, if foreign pathogens enter into our body systems, then our immune system will immediately respond to kill them. Okay, by which manner it will kill? It will increase the body, that is temperature of the body. Okay, so fever is nothing but it is that of a symptoms of certain pathogens, that is foreign pathogens entering our body systems. So that if our temperature is more 101, 102 degree Fahrenheit, it means that so many pathogens, foreign elements, foreign pathogens, disease causing pathogens entering our body systems. So our immune system will increase the body's temperature so that such pathogen will die. Okay, for killing the foreign pathogens, our immune system increase our body temperature so that such pathogen will die. You know that those pathogens entering our body, they have also enzymes, but that enzymes can't survive in high temperature because such enzyme also can act as normal body temperature. The foreign pathogens coming into our body, that means such pathogens have also enzymes. That enzymes can only act on normal temperature. If our immune system increase the body temperature to that of more than 37 degrees Celsius or that of Fahrenheit, that means 99, 100 Fahrenheit, then such pathogens will die because they can't the brunt of the high temperature, because they are temperature specific, because they can have to bear the normal body temperature in 37 degrees Celsius. The normal body temperature or 1-2 degree plus or 1-2 degree minus, that means enzymes can act perfectively. As our body temperature is 37 degrees Celsius, so the normal that enzymes act in our body, they can also act in that 37 degrees Celsius. If 2 to 3 degree more, that means they can sustain, they can function, or 2 to 3 degree less also, they can also function. But if it is to that of more than 40 degrees Celsius or that of 30 degrees Celsius or 25 degrees Celsius, in such condition enzymes can't act properly. Okay, because they are, that means temperature specific. They will have to act on it at a normal temperature. So the foreign pathogens will die, but at the same time also our bodies, that means in a war you might have seen that if two that means two groups fight each other, two brothers fight each other, both will be the loser. That means one is winner, one is loser. That is, but both will be to some extent losers. Similarly, foreign pathogens will die. Foreign, that means foreign pathogens bearing such enzymes also will die. But that our enzymes also will be denatured. That means for some days, after fever, for some days you are not feeling okay. You are feeling weakness. It is due to that our enzymes are not properly working. Okay, properly working. I had already told you that you don't have to take the hot food or don't have to take that of extreme cold food. Okay, because in such condition that enzymes denature, enzymes will not be released, and that means our that means foods we have taken can be properly digested. And hot food you don't have to take because it will have to, that is, damage our gut systems, damage our stomachs, esophagus, it will have to damage. So don't have to take the extreme hot food. Okay, that is normal temperature food you must have to take. Okay, students, that means such enzymes, that means enzymes roles are not to start any chemical reaction. They have no role in starting of initiation of any chemical reaction. They only support to speed up the chemical reaction in our body. Okay, and enzymes also can destroy themselves. They can't have to be, because if you have to, that means in chemistry you might have, suppose you have to some gram of enzymes, that means some grams of catalyst you have taken to speed up the chemical process. After the end of that chemical reaction also, that catalyst, what amount of catalyst you have taken, that will remain same. Okay. Similarly, the enzymes which are involved in the process of chemical reactions, that is body's biochemical reaction in our body, they will remain same. They will remain. They can't be altered, or they can't be changed, or they can die. Okay, so they will remain, and they will have to ready for another chemical reaction. Only they will support the speed of the chemical reaction. Okay, and today what you are going to discuss mechanism of action, how enzymes, that means support in chemical reactions. As I have told you that enzymes act like of dynamites, and that means if you have to cross a hill, you have to climb up, climb down, so many energy you have to require, so many times you have to require. But that that if there is a tunnel through that of dynamite, say you have made a tunnel with through the hills, then you can have to reach the opposite point easily. So similarly, that chemical reactions, biochemical reactions occurring in our body are taking the so many times if there are no enzymes. But so enzymes are helpful in that they speed up the chemical reaction. But the initial energy and the final energy, that is energy of the substrate and the energy of the product, will remain same. There is no alternation. They can't have to alter any energy process. Okay, they can't alter any energy process. Substrate energy and that of a product energy will remain same. There will be no alternation. That means enzymes have no role in initiation or starting of any biochemical reaction. They only helpful in to speed up the biochemical reaction in our body. So this is that of mechanism of action of enzymes. You should have to understand it mindfully. Okay, mindfully. You see that x-axis. This is the x-axis. This is the y-axis in a general graph. You do it. And you see that x-axis shows what? Progress of reaction. Y-axis shows potential energy. In that of in examination also question asked that in mechanism of action of enzymes, x-axis and y-axis respectively shows what. X-axis shows, students. X-axis visualizes
Process of
Progress of
reaction.
reaction.
progress of action, reaction, and that of y-axis shows
Potential energy.
potential energy. Very good. Okay. And this line, what I have drawn in middle, that is the substrate. Okay. That substrate will convert it into that of product. So that you see that. That means without enzymes, how that you see that without enzymes, that means how product become possible. You see that you mark it. That means this is the product. That means here is the product. That is, it is without enzymes. It is without enzymes. Okay. And here you see that this is that this is the transition point. This is the point of transition. That means you see that. That means substrate transform into product. That is substrate transform into product. That means yesterday I had told you that that is bonds will be broken. The bonds of substrate will be broken and new bonds will be formed. That is the chemical reaction. Same thing happens here. So that you see that this is the chemical, this is the biochemical reaction without the support of that of enzymes. So that means energy is required. Without energy, that is substrate can't be transformed into product. Okay, without energy, substrate can't be transformed into product. So the requirement of energy is essential, and that energy is called activation energy. Okay, that energy is called activation energy. You see that this energy is called activation energy. That is activation energy. What is activation energy? The energy which is required by the substrate to transform into product is called activation energy. That means this activation energy, because substrate can be transformed into product immediately. That means it will take times. bonds will be broken, new bonds will be formed. So it is a time requiring process, can be done urgently. So that means immediately it can be happen. So that is activation energy. So more energy is required. You see that activation energy is more, and here is that of, you see that. That means substrate will be transformed into product. That means bonds will be broken, and that means so many intermediates will be there. That will intermediate for that of changing substrate. Suppose you have got a job in Mumbai. That means you don't know about the Mumbai. That means how that houses are available on rented basis. So you should have to talk with the intermediate. That means a middleman. Like this also. That means when substrate will convert into product, that means it will have to. That means it will have to contact with that of intermediates. So this is called that of a transition point. This is the transition point. Transition point. And this point is, and the substrate and that product formation will start from here. That means from this point to that point, the bonds will be broken. The bonds of substrate will be broken. And from that point to that final point of product, that means new bonds will be formed. So the breaking of bonds and formation of bonds. That means in such process, that is requirement of energy. So many energy is required. That is called activation energy. Activation energy. Energy which is required by the substrate to transform into product is called activation energy. And more activation is required. Activation energy without enzymes. Without enzymes. Okay. Without enzymes. Then you see that. Then you get the support of enzymes for that of biochemical reactions. So in this process, what happens that you see that. That means in such process you see that. That means that means activation energy. Here is that you see that is you require this much activation, this much activation, this much energy is required. For that of this process, more energy is required. Here for enzymes, less energy, that more speed of reaction. More energy, more speed of reaction. So that you see that what happens that if enzymes, that means if enzymes are involved in such process, they will have to lower the activation energy. Their main function is lower the activation energy. You see that activation energy required to certain extent when enzymes involved. In that case, activation energy is lowered to certain extent. So that what enzymes do in such case? Enzymes that reduce the activation energy. That means lower the activation energy to speed up the that is biochemical process. To speed up the reaction. So this is the activation energy of energy without enzymes. This is the activation energy. That is activation energy with enzymes. Okay, with enzymes. And here you see that means this is substrate. That is substrate means that is energy possessed by the substrate. Yes, this is the energy possessed by the product EP. Okay, so you see that here what that means what enzymes role in it. Enzymes that means what enzymes do here. Enzymes that lower the activation of energy. Activation energy. That means lowering activation energy is the most important work of the enzymes in biochemical reaction. Okay, activation energy. You see that. That means enzymes here, what it does? That means activation, that is energy requirement. It lowers the energy requirement. So that you see that it is taking so many times for getting the product. But here you see that speedily you have to get the product. It is due to that of role of enzymes. So enzymes what do? That lower the activation energy. That is the important concept of this graph. In this graph of that of mechanism of action, how enzymes lower the activation energy. Activation energy. Without energy, if you will transfer substrate in product, more energy will be required. The activation energy will be more. If enzymes will participate in such reaction, then that means activation energy will be lowered, and then that biochemical reaction will be done speedily. Okay, done speedily. And in such case, that means whatever be energy in that of substrate, that will be similar to the energy in the product. There will be no change because enzymes can't alter the energy process, can't alter the energy process, or can't initiate any biochemical reaction. The concept should be clear that enzymes help, don't initiate any chemical reaction. Enzymes can destroy in such chemical reaction. After chemical reaction, they also become fit for another chemical reaction. Okay, that you must have to understand. So here, that means here in this graph, what you have understood that without energy, without enzymes, more activation in energy is required for converting substrate into product. But if you will have to use the help of, that means if you have to take the help of enzymes, if enzymes are utilized in that chemical reaction, are involved in that chemical reaction, they will lower the activation energy. They will lower the activation energy so that the biochemical reaction will be occurred without, that means speedily, will occur speedily, and that means and the final product will come out. And in this process, energy in the substrate or the energy in the product can be altered. They will remain same. And then after completion of that of biochemical reaction, that such enzymes will be ready for another biochemical reactions because they can destroy in such reaction. They can be destroyed itself in that reaction. They only will have to draw the substrate energy to that of a product energy. They will have to only help in conversion of substrate into product. That's about the mechanism of action that also given in your NCERT. You must have to look it, and you try to you see it, and that means how that graph shows and what I have taught it. And if you have any doubt persist in your mind, please you ask me. I'll have to explain it again. Have you any doubt in here, students? Yes, Maronika, sir.
Define the
Repeat the
transition
definition
state.
of yes, activation energy. Yes, activation energy. Activation energy, students. Energy required by substrate to transfer into product. Again, I am writing that what is activation energy? Okay, what is activation energy? I am just writing that energy required by the substrate to transform into product is called, okay, activation energy. Is called activation energy. Energy required by the substrate. This is the substrate. This substrate require what? Energy. Without energy, that can be transferred. Okay. You see that, students. That means suppose here is a fuel. Here is a fuel, and oxygen is available here. Do you think that? That means fire will automatically, that is this fuel will automatically burn? No, because our body itself is a fuel. Okay, that means you can also burn. So that as you are organic made up of organic matter, so that suppose this is a fuel, and oxygen throughout the oxygens. But there must be a, that is, that means ignition point. That means there must be a source from which, that means you can have to burn this fuel. Similarly, in that enzymes, all parts of enzymes are not required for that of a chemical reaction. So only that some pockets, some crevices, they are found in that of some points of enzymes, and they are required for that of a chemical reaction. So that you see that I'm just telling about that. That means you know that lock and key lock. That means you are opening a lock by using a key. That means the size of that of a lock, that means where the hole, that means where it is locked, closed, that means that size to that of key size is similar, so that it is attaching each other and opening it. Similarly, that means enzymes also, that means there are some lock and key type. That means there are some active sites, and there are substrates. That substrate can match to that of active site. So there are so many active sites, there are so many enzymes in our body. That means there are 1300, that is 1300 enzymes in our body, and 1300 enzymes in our body, and there are certain cofactors, and that cofactors nearing to that 5000 to 10,000 cofactors. And when the cofactors come in, cofactors also act like that of enzymes. We'll have to know in that latter stage of this chapter about what are cofactors. I'm just telling about that enzymes, that means convert that cofactor into that of enzyme like role, just like derived proteins, just like derived lipids. Similarly, that of cofactors are act like that of enzymes, and they also help in metabolic reaction. So what I am telling about that, there are certain that you see that in an enzymes there is a pocket, there is a crevice, and through which substrates come and match it, and then chemical reaction occur. Then that will be converted into that product. That product will not be matched in that pocket, so they will come out, and after that enzymes are free and ready for that of second reaction. That is called lock and key hypothesis. Okay, that is called lock and key hypothesis. I'm just telling about that lock and key hypothesis. Okay, you see that is lock and key hypothesis. Okay, and it is proposed by Emil Fischer. Okay, Emil Fischer proposed that lock and key hypothesis in 1894. In 1894 AD. Okay, that is Emil Fischer proposed lock and key hypothesis. Students, you see that doctrine, principle, theory, hypothesis. That means hypothesis means it is not 100% true. That means hypothesis is a term which is not 100% true. There are 20-30% lacunas here, loopholes here. There are certain points which are not clarified by that hypothesis. But if you come to that of doctrine or principle or theory that are scientifically proved and 100% true, 100% true. Doctrine, principle, theory, such terms scientifically, experimentally proved and 100% true. But whenever we'll have to come in contact with term of hypothesis, this is not 100% true. So lock and key hypothesis, which was proposed by Emil Fischer in 1894. what is said that you see that students, suppose you see that this is an enzymes, and here is that of the pocket. Okay, it is a pocket. That is active site. It is an active site. Here you see that there is a substrate. There is a substrate. That substrate came in contact with that of here is that this one is enzymes, this one is substrate. When enzymes will come into that of contact with that of substrate, then you see that, okay, you will see that in such case, what happens that means it will have to attach with it. Okay, and this is called what? Enzymes substrate complex. It is called enzyme substrate complex. Okay, that substrates come to that of active site. This is called pocket or active site. This is called active site. Active site where biochemical reaction occurs. So substrates come in contact with that of active site, then that is chemical reactions occurs. So that enzymes plus substrate is equal to enzyme substrate complex. When substrate comes in contact with that of enzymes pocket or active site, that is chemical reaction occurs. So from where? What we'll have to get? We'll have to get that product. Okay, we'll have to get that product. We'll get that product, but that product is of differential. That you see that product you got. That product are not matching in that pocket, so it can't remain in such pocket, and that products come out. Okay, you see that product comes out. That product comes out. Okay, when the products come out, that enzymes remain free. You see that enzyme remain free and ready for another chemical reaction. Okay, another biochemical reaction. So in such way, enzymes help in that is multiple chemical reaction. A particular enzyme, say pepsin, in our body. That means that is involved in lots of biochemical reactions occurring in our body. That means that is helpful. That is one enzymes can support that millions of chemical reaction throughout the life of our body. So that you see that this is the active site. That lock and key hypothesis. This one is a lock, and this is what substrate is a key. That means when substrates come in contact with that of lock, then you see that whenever you are pushing that of key inside that of lock, then the door opens. So similarly, that means here, that means when it attaches to that of substrate, that means chemical reactions occurs. So start of chemical reaction. When chemical reactions occur, it will have to what? That is enzyme product complex. So product remain. So after chemical reactions, that means product come out. That is enzyme product complex, EP complex. So but that products can remain in because they are not fit to remain in that pocket. So they will come out. When they will come out, that products come out. That means enzymes remain free. Enzymes remain free and ready for another biochemical reaction. So this is that is Locke hypothesis. Emil Fischer given in 1894. This is not given in your book. Okay, this is not given in your book. This is extra, but we must have to learn it. That is, it is very important that we must have to learn it. That Locke hypothesis. That means what you know that this one is substrate. This is a pocket. This is the active site of enzymes. Where that means when substrate will come in contact with that of active site, then chemical reaction will start. And then chemical reaction starts. That means that is ES complex, that is enzyme substrate complex. Then chemical reaction will start. Then product will come out. That is EP complex, enzyme product complex. But that products are not matching in that pockets. So they will come out from that of enzyme, that is from that area they will come out from that pocket. So product come out, final product you get from substrate, you transform into that product. Then enzymes remain free and ready for another biochemical reaction. So nothing. But another point, student, you see that there are certain substrate also. That means there are certain substrate also. That means they will, why they are also coming. That means particular substrate coming in contact with the pocket will initiate chemical. That means chemical reaction will start. But there are certain substrates. If they come in contact with that pocket, no such chemical reaction occur. No such chemical reaction occur. Okay, that no chemical reaction occur. So about why such things happen, that means Emil Fisher don't tell anything about it. Okay, so owing to that, we think it is regarded as a hypothesis. But another theory, that is induced fit theory. Induced fit theory. That is another theory that is induced fit theory. Okay, that is induced fit theory. Fit, you know that fit theory, that means it has clarified that there are certain substrates, that means who coming in contact with that of pockets or that of active sites, why they don't help in reactions. That means why they don't help in chemical reactions. That means that things has been clarified by induced fit theory. Induced fit theory. So what happens with that, students? You see that, but in your book it is given that when enzymes, but in your book it has given when enzymes come in contact with substrate, that is enzyme substrate complex will be formed. Then after chemical, that is reactions, enzyme product will be come out, that is enzyme product complex will be formed. From there product will come out, then enzymes ready for another biochemical reaction. It has given the process given, but it has been told by that Emil Fisher in terms of lock and key hypothesis. It has not been explained. Okay, so that, and there are certain loopholes, that there are other substrates which coming in contact with that of pockets, but no chemical reaction occurring. So that lacuna, that loopholes, that regions, why it is not happening, has been clarified by induced fit theory. You see that there are certain substrates. Suppose you see that what they will do, such substrate, when come in contact with that of enzymes, they will have to, because such pockets are not ready in enzymes, such pockets are not ready. When they will come in contact with that pockets, that means they will induce, they will encourage, they will ask, or they will make requests to that of enzymes to make a suitable pocket for them. So enzymes will develop a suitable pockets so that such substrate will come in contact with them, and then biochemical reaction will occur. Okay, so that in such case, that induced fit hypothesis, that means those enzymes which have pockets and substrates which are ready for there, they will obviously come and they will take the, that is chemical reaction will occur. But there are certain substrates who, in spite of coming in contact with that pockets, don't help in chemical reaction. That has been clarified by induced fit theory. You see that. Suppose this is that is it is an enzyme, and here is a substrate come in contact with Okay, when substrates come here in coming in contact with, that means it will induce enzymes to create the pocket, to create an active site, so that enzymatic reaction will occur, or it will be, so the biochemical reaction will be occurred at full place. So that in such case, what will happen, that means such enzymes will develop pocket for it. Okay, will develop pocket, because substrates has capacity to induce, to request, to ask the enzymes to make a suitable place for biochemical reactions. So in such case, that means these enzymes will develop a pocket. Okay, will develop a pocket because induced, that means such enzymes in contact with that of substrate will develop a pocket. After that, that that will come, that means substrate will attach with it, so that is enzyme substrate complex will be formed, and then such process will continue. Okay, and it is because of that of certain substrates which will induce the enzymes to create a pocket for them. But there are certain inhibitors. There are, you know, that inhibitor, the term inhibition, inhibitor means those who are, that is suppression. That means not causing, not, that means stop the chemical reaction. They are called inhibitor. There are certain inhibitor also, inhibitors. If they will come in contact with that, if that is an inhibitor, it will come in contact with that of a pocket. But here what that, because they have no power of inducement, because they can induce the enzymes, that means to make a pocket for them. They pocket for them because inhibitor has no such role. Inhibitor have no such role that they will have to approach the enzymes to create pocket for them. To create pocket for them. Okay, because they have no such role, no such activity, no such role to approach the enzymes to create pocket for them or to create active site for them. They are inhibitor. So about such inhibitors, that means Fisher don't tell. Fisher remains silent about the role of inhibitors because inhibitors have no such role in that of asking the enzymes to change its position so that they will be helpful in that of biochemical reactions. Okay, students. So this is the induced fit theory, and what I have told you that this is that is lock and key hypothesis. Lock and key hypothesis. This is the induced fit theory in which the substrates which are coming in contact with that of enzymes don't make help in biochemical reactions, but how they are also helpful in biochemical reaction, it has been clarified by that of induced fit theory. Okay, so this is all about that of lock-key hypothesis and induced fit theory. Okay, and you see that means in almost all cases, that means enzymes play the pivotal role. Enzymes play the pivotal role in that of metabolism inside our body. Okay, in that of anabolic process or that of catabolic process, that enzymes roles are the pivotal ones, and that enzymes helpful. And I have told you that all the enzymes are proteinaceous. All enzymes are proteinaceous, and even that of substrate also, they are also proteinaceous. Okay, so that they will have to mix together and will have help in that process of biochemical reactions. But there are certain enzymes. I have told you that means non-proteinaceous enzymes. Have you remembered that? That is, I have told you that non-proteinaceous enzyme, students.
Ribozyme.
Ribozyme. Yes,
Ribozyme.
ribozymes. Another non-proteinaceous enzymes you have to remember today. That is, it is ribonuclease P. Okay, ribonuclease P. Another non-proteinaceous enzymes is a ribonuclease P. One is that of ribozyme. Another one is ribonuclease P. Both are non-proteinaceous enzymes, not made up of a protein. Non-proteinaceous enzymes. Okay, that is ribozyme and ribonuclease P. You see that ribo terms, that is they are RNAs. Okay, they are RNAs. And they are ribonucleic acid. Both ribozyme and ribonuclease both are RNA. That is ribonucleic acid. But both have enzymatic activities. Both have enzymatic activities. RNA is a ribonucleic acid. Okay, it is a nucleic acid. But despite being that, RNA has enzymatic power, has enzymatic activities. It can also play the role of enzymes. But DNA have not such role as that of a ribozyme or ribonuclease. DNA is there. DNA is there because they can have to helpful in that of different biochemical reactions occurring in DNA. So DNA is there. So but DNA is that is proteinaceous. But that of ribozymes and ribonuclease, they are both that of non-proteinaceous enzymes. Non-proteinaceous enzymes, and that means both have enzymatic activities. Both do that of enzymatic activities. Okay. So in your that is NCERT books, it has given that enzymes plus substrate that gives rise to enzyme substrate complex. Enzyme substrate complex after chemical reactions convert into that of enzyme product complex. As products not matching in the pockets, they will come out from that of pockets. So pocket remain free, so that products come out finally. So substrate coming in, substrate with the help of enzymes, that means speed up the chemical reactions, come in, that means convert into enzyme substrate complex, enzyme substrate complex after biochemical reaction, transform into enzymes product complex, and products not suitable in that pockets will come out from that of pockets, and that means enzymes will remain free. So that has given in your insert books, and in your insert books it has given elucidate that, that means there is some steps of biochemical reactions. Biochemical reaction. Biochemical reaction inside our body occurs to that of four stages. Four stages. First stage is that is substrate will come in contact with that of enzymes, because enzymes have certain that are pockets, that is active sites, and after that enzymes product complex will be formed. Then in that enzyme, that is a enzyme substrate complex will form. In that enzyme substrate complex, that means biochemical reaction will occur, will enhance, will be boosted, and so that it will transform into that product, that is product formation of product is that of a second stage, so that then product will come out from that of enzyme product complex and will remain free, and so that it will also they will be remain free from that of enzyme, that is product complex, that is products remain free and enzyme also remain free. So these are the four processes by which enzymatic actions occurring in our body. Okay, that is the stages that you'll have to remember, and in notes I'll have to send you immediately, and you'll have to learn it. Okay, and in this way, that means we have that is a mode of that is a reaction, enzymatic reactions occurring in our body, lock and key hypothesis, induced fit theory. I have explained it correctly, and I might have understood it. And then that is tomorrow we'll have to know about that there are certain factors which that check the enzymatic actions. We'll have to know about that of temperature, about that of pH, about that of pressure. Okay, in that case we'll have to learn about that. Then we'll have to know different types of enzymes. Okay, enzymes. Then we'll have to know that of coenzymes, cofactors. You'll have to know about that of holoenzymes, apoenzymes. We'll have to know about them tomorrow, and we'll have to know about that of certain that is elements. That is elements which are also helpful in that of that is chemical reactions helped by that of enzymes. Okay, so that in such a way tomorrow or by day after tomorrow that you will have to finish this chapter. And if you have to doubt persist in your mind, develop in your mind, you must have to write down and to inform me and have to clarify your doubt. Now students, you come to that of questions. Okay, we'll have to now ready for that of answering the questions. The first questions in our be that match the columns. First question, students, match the column. Match the columns. Okay, that is column I and that of column II. After writing the questions, I'll have to turn aside to the screens and will ask you that you answer immediately. You'll have to answer. But whenever I am writing, you don't have to answer or don't make any controversy. Okay. So that come to that column one, that is purine. That is purine. B. Pyrimidine. Okay. Then C, you have to come to that of structural, that is structural polysaccharide. Structural polysaccharide. Okay, and that of storage polysaccharide. Then we'll have to write down that of I. Okay, we'll have to write down that of glycogen. You write down that. You also write simultaneously with me that cellulose. Okay, triple I, that of uracil and guanosine. Uracil and guanosine. Okay, you see that A, B, C, D. A, B, C, D. That is what I have written. 9. A, B, C, D. You see that I'm just writing. You'll have to write with me. I, double I, B, triple I. B. I, then I, B, triple I. Then C, I, B, triple I, D, I, B, triple I. Okay, students, can you give the answer? Yes, Sunday, I, B, cut. Okay, no wrong answer. Yes, that is right answer. Okay, right answer Sunday. That is Adhyasa Dubey also right. Jyotiranjan, no. Jyotiranjan wrong. Wrong answer. Smaranika Patra right. Anamika wrong. Tushar Ranjan wrong. Sunday yes. That Pradimna Shahu no. Mona Lisa Biswajit no. Anamika Kumari yes. Anamika Kumari. You see that students, yes, Priyanka Bagh, yes, right answer. Aditya Shahu, right answer. Satya Prakash, right answer. Then anyone? Okay, you see that students, you see that purine. Purine is a guanine. Pyrimidine is a uracil. Okay, structural polysaccharide is cellulose. Storage polysaccharide, glycogen. You know that glycogen, that means our body store glycogen. Okay, so it is a storage polysaccharide, glycogen. Structural polysaccharide is cellulose, and pyrimidine is uracil. So I is IV. Pyrimidine is uracil. Structural polysaccharide is cellulose. Storage polysaccharide is glycogen. Storage polysaccharide glycogen. You can mark it II. That is controversy II. Then you will have to see that structural polysaccharide cellulose. So blindly you will have to give that answer. Okay. Give that answer to that of sheet. IV, triple II, and I. Okay. Then come to that of question number 2, students. Question number 2. You see that amylose and amylopectin. Question number 2. Amylose and amylopectin. Amylose and amylopectin are two components of are two components of I'm giving you option cellulose, option B starch, option C is that of glycogen, and the option D is that of chitin. Students, you give answer. Yes, Maranika Vishwajit, brilliant answer. Starch is the right answer. Yes, Adhyasa Dubey, Priyanka Bag, Anamika Kumari, Sanvi Parija, Aditya Sahu. Okay, brilliant answer. Swayam Pragya Sahu, brilliant answer. Swayam Pragya. Then come another students. That means not. You see that? Yes. Beula Khora also starch. Very good answer. Okay. The brilliant answer. You see that amylose and amylopectin are two components of starch. So right answer will be that of starch. Then come to that of question number 3. Select the correct pair. Okay. Question number 3, students. Select the correct pair. You will have to choose which one is the correct pair. The question number 3 is select the correct pair. Select the correct pair. You have to select which pair is correct. Pentose, that is galactose. Okay, pentose is galactose. Then tetrose, tetrose. That is erythrose. Okay, tetrose is erythrose. Then come to disaccharide, ribose. Disaccharide, ribose. Okay, disaccharide, ribose. Then hexose, maltose. Hexose is maltose. Can you guess, students, which one is that right one? Yes, Sanbit Parija. No. Yes, Maranika Patra is the right answer. Right answer. Okay. Adhyasa Dubey also right answer. Right answer is Vishwajit. No, it is wrong answer, Vishwajit. Wrong answer. Akhilesh Panda. No, wrong answer. Then any students? Okay, you see that Priyanka Bag D, wrong answer. Aditya Sahu, right answer. Right answer by Aditya Sahu. So you see that, students. Pentose are ribose. Okay. Disaccharide is what? That is disaccharide. We'll have to form in that of disaccharide, in that of maltose. Okay. Galactose is hexose. So tetrose is erythrose. So right answer is tetrose. Tetrose are erythrose. So this is the correct pair of tetrose. Then come to that of question number 4, students. Okay. come to that question number 4. Nitrogen bases of DNA nucleotides are attached by. That is question number 4. Mindfully you listen. Nitrogen bases of DNA nucleotides are attached by. Okay, I'm giving you option mindfully by hydrogen bond, by ester bond, by peptide bond, by phosphodiester bond. Which one is the right answer? Biswajit Mahalik, Tushar, Anamika Kumari. That is right answer, Anamika. Tushar Ranjan, right answer. Akhilesh Panda, right answer. Smaranika Patra, right answer. Atyasa Dubey, also right answer. Biswajit Mahalik, wrong answer. Priyanka Bag, wrong. Okay. So the right answer is, students, that is hydrogen bond. Okay, that is hydrogen bond. On that day I had just shown you that. You have remembered that once. Okay, this is the nitrogen base. That is, suppose this nitrogen base is adenine, and this is another nitrogen base. Okay, that is, suppose that is thymine. That will be joined by that of a double hydrogen bond. The double hydrogen bond AT. I have told you that this is hydrogen bond. Okay, hydrogen bond. So that answer is nitrogen bases of DNA nucleotides are attached by hydrogen bond. Last questions of today. Okay, last questions of today. Which of the following statements is wrong? Last question of today, students. Which of the following statements is wrong? Question number 5. Which of the following statements? Which of the following statements is wrong? Which of the following statement is wrong? Okay. Cellulose is a polysaccharide. Okay. Cellulose is a polysaccharide. B. Cellulose is a polysaccharide. Uracil is a pyrimidine. Uracil is a pyrimidine. Mindfully listen and learn and write. Sucrose is a disaccharide. Sucrose is a disaccharide. Glycine is a sulfur containing glycine is a sulfur containing amino acid. Can you? Yes, Aditya Saho, right answer. Anamika Kumari, Adyasa Dubey, Smaranika, wrong. Tushar Ranjan, right. Vishwajit, right. Sanbhi Parija, right. Smaranika Patra, right answer. Smaranika Patra, right answer. Okay, okay, students, you see that. Cellulose is a polysaccharide. This is right. Uracil is a pyrimidine. This is also right. Sucrose is a disaccharide. This is a right. Glycine is a sulfur containing amino acid. It is a wrong. Okay, methionine is a sulfur containing amino acid. So this one is wrong. So this is the D is the right answer because this statement is wrong. Thank you, students. Thank you very much. Okay, today I'm just sending you the bio assignment 2. Okay, you should have to do it within 48 hours and then submit. Okay. submit, and you will have to use that new WhatsApp groups formed, and you should have to utilize and send your answer and notes, all these things by assignment, everything that you will have to send it me and also communicate with that WhatsApp. Thank you very much, students. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.